Alright, hello class. We're looking at section 3.2. Now this time we talked about all these tests, all these methods we use to graph polynomial functions in class. So please get out your notes from class. And I am only going to do, once again, the second page where we use all the tests to graph. Okay, so let's scoot some things over here. Okay. Let's look at number 20. Number 20 says, and this is what I want you to do. Complete the following. Use the leading coefficient test to determine the graph's end behavior. Find the x-intercepts. State whether the graph crosses the x-axis or touches the x-axis and turns at each intercept. Find the y-intercept. Graph the function. And I will add one more thing. Check to make sure that you haven't crossed the x-axis at a point that was not one of the x-intercepts. That's a common mistake. And count the number of turning points to make sure you haven't gone over the number of turning points. Okay, so number 20. The first thing I see is that is factored, which makes me happy. So I'm going to use the leading coefficient test. Remember, that's really two things that we're looking at. The first thing is, what is the degree of this polynomial? If I were to multiply or expand this polynomial out completely, this would be a third degree polynomial. So I know my ends are going in opposite directions. Odd opposite. Then, since the leading coefficient here is 1, which is positive, I know it's going to rise to the right and fall to the left. That's what the ends of this polynomial will look at. Okay, next, my x-intercepts, okay, x-intercepts, since it's already factored, I know I look at this first factor of x squared, and I get an intercept of x equals 0. And since it came from a factor that is squared, that has an even exponent on it, it's going to touch. Okay, so let's plot that. It's going to touch. The second x-intercept we get is x equals -2. Since it came from a factor with an exponent of 1 on it, that's odd, it's going to cross. So let's see, -2 would be here. Now find the y-intercept. The y-intercept is at y equals 0. Hey, that's the same as the x-intercept. That's interesting. And now I just do my best to kind of sketch it. I know I'm coming from the negative part on the left, and I'm heading up to my first x-intercept at -2, and I'm supposed to cross it. Okay, now I have to turn around and go back to get to the next intercept at 0, and at 0 I'm just supposed to touch, so just make a little bump there, and then I turn around and I keep going, and that's it. That's number 20. Okay, let's try 21. Okay. Again, let's do end behavior first. Okay, this is a fourth degree polynomial. That is an even degree, and therefore the ends will go in the same direction. The leading coefficient is +1, so I know it's opening upwards. Both ends are going up. Now, they didn't factor this for me, but I think we can factor this. Okay, so let's do it down here. X to the fourth minus 4x squared equals 0. Factor out an x squared, and I'll be left with x squared minus 4 equals 0. Keep factoring, I get x squared minus 2x. I'm sorry, x squared times x minus 2 times x plus 2 equals 0. So that leaves me with x-intercepts of x equals 0. Now that came from the x squared factor. That's even, so it's going to touch. X equals 2, that one's going to cross. And x equals -2, that one's going to cross. Okay, so let me plot those back up here on my graph. 0, 2, and -2. Then my y-intercept is going to be 0 again. Okay, that's kind of boring. And so let's see. So I'm starting up here, and I'm going down, and I'm crossing at 2, -2, I apologize, Then I have to turn around and get back up to 0, but I just touch at 0. And then I have to turn around to get back through 2, and I cross at 2, and then I keep going. So this has a lovely W shape. Now remember, the question is, how far do these little valleys go down here? And the answer is, that is beyond the scope of this class. Okay, we don't do that in this class. If you want to figure that out, you have to take calculus. All right, now everyone wants to take calculus. Okay, let me pause, and we'll do the last two in a moment. Okay, now let's finish the two graphs on section 3.3. I didn't leave us enough room on number 22, so I'm going to use my scratch paper here. So first, the first thing I notice about number 22 is this polynomial is not written in descending order of power. So I'm going to rewrite it as negative x to the third plus 3x squared. So that's the first thing I'm going to do. Now I'm going to figure out the end behavior. This is a third degree polynomial, so the ends go in opposite directions, odd, opposite. The leading coefficient is -1, so I know it's going to fall to the right and rise to the left. It's going to do that. Okay? Now, let's find our x-intercepts. So, to find our x-intercepts, we take our, polynomial, and we say it equals 0. Okay, so let's factor out, I'm going to factor out negative x squared. How about that? I'll be left with x minus 3 equals 0. So I get two x-intercepts. Let me make my list of them over here. There we go. X-intercepts. I get x equals 0 from the x squared factor. And so since it came from a factor with an even exponent on it, it's going to touch. Then I get x equals positive 3, and it's going to cross. When we get our y-intercept, again, the y-intercept is 0. So let's plot the points we've got. 0, 0, and let's see. 1, 2, 3, x equals 3 is a x-intercept. Okay, so I'm coming down from the left, and at 0 I just touch. So I touch it and turn around and go back. But now I have to turn around to get back to 3, and I cross it, and then I continue downward. And that is 22. Okay, let's do 23. 23, end behavior first. This is a fourth degree polynomial, so the ends are going to go in the same direction. The leading coefficient is positive 1, so I know they're both going up. Okay, so let's find, okay, I'll be boring and I'll tell you what the y-intercept is right away. Look, it's 0 again. If x is 0, y is 0. Now let's find our x-intercepts. So I'm going to take my polynomial of x to the fourth minus 8x to the third plus 16x squared and set it equal to 0. Remember, first thing you always do when factoring is greatest common factor. Factor out the x squared, I'm left with x squared minus 8x plus 16, which conveniently factors into x minus 4 times x minus 4. Now we shouldn't leave it like that. This is a repeat on this factor of x minus 4, so I need to condense it. This is x squared times the quantity x minus 4 squared. And now I see that my x-intercepts are at x equals 0, and it's going to touch, and x equals 4, and again they're going to touch there. Okay, that's interesting. So let's come back up to my graph. X equals 4, 1, 2, 3, 4, and x equals 0 is already there. Okay, and they're touching at both. Okay, so how would we do this? So I'd be coming down from the left, and I hit x equals 0, and I just touch it, and I turn around and go back. Now I have to turn around to get back over to x equals 4, and again I just hit x equals 4 and turn around and go back, and then I continue up. And look, there's that lovely W shape that we see in fourth degree polynomials sometimes. And remember, how high is this bump right here? I don't care. Okay, in this class, as long as I see the bump, it doesn't matter how high it goes. Alright, that is section 3.2, graphing polynomials.